finite element methods. In this TED talk, my topic is about comparative between FEM model for FDM parts and their approach to a real mechanical behavior. Abstract. Laminated parts made of FDM in fused deposition modeling are becoming increasingly popular in last years. This incremental can be explained due to their potential in the field of the manufacturing in order to allow us to make any kind of geometry, but in another way these parts have not enough value of stiffness and strength to get an approach to a final constructive part. However, advantage of nowadays finite element method programs allows us to analyze the behavior and main manufacturing properties in order to get previously mentioned structural parts. Then we must need to accurately predict the response of composite structures to different load cases. In this way, the adequate modeling tools must be developed. The motivation of this article is to contribute to this development, making numerical simulations of two different composite structures with a pliable approach and analyze obtained results. Introduction. Previous studies were focused on building geometrical prototypes. However, recently developments in the field of rapid prototyping enabled some of the prototyping method to achieve a lathe manufacturing technologies to produce the final product directly. This effect allows an important reduction in terms of process time reduction and consequently cost reduction. In same way, solid free-form fabrication technologies like fused deposition modeling (FDM) used to get final parts can be observed as the technology to reach materials and energy saving is compared with another process. Laminated parts made of fused deposition modeling are become increasingly popular in the last years. This increment can be explained due to their potential and their capability to make any kind of geometry, but in other way these parts have not enough value of stiffness and strength to get an approach to a final constructive part. However, advantages of nowadays finite element method programs allows to us to analyze the behavior and main manufacturing properties in order to get previously mentioned structural parts. Mm, Then it will, then it we must need to accurately predict the response of composite structures to different load cases. In this way, the adequate modeling tools must be developed. Before doing this, some basics regarding to laminates should be reviewed. Non-homogeneous materials are formed by two or more dissimilar constituents called phases. Also called phases. Predictions of their behavior is one of the main goals in the field micromechanics science. It must be determined by each phase behavior and also by the phase arrangement, which is the geometry and topology of each of the constituents. In this case of RP rapid prototypic part, the compositions of each layer should be considered in different way than other layers composites. In typically composite parts are formed by two constituents, matrix and inclusions. The matrix is a topologically connected constituent, while inclusions are distributed in it. However, diffuse deposition method technology, we should take into account that there is a wire rasters that should be analyzed as inclusions into a whole matrix. Means the holes are space between the wire rasters and also between the layers. So the FDM part we can consider on tropic case, and in our case continuously ABS fibers with two differential direction properties. In this diagram, we can see that A and B, there are both diagram. The A refers the layer fiber crossed composite, and the B is the layer unidirectional composite like FDM parts. These are FEM parts and these are FDM parts. Layers. Composite components are in most cases formed by a layered laminated that consists in a certain number of layers which bond together to form the laminate. In the case that we studied within the paper, a single pie represents a unidirectional reinforced thin composite. A comparative between two different FEM models of part manufactured using fused deposition modeling and their approach to reality. This should be a first step to observe main parameters in the part manufacturing and mechanical failure characterizations of part depending on parameter treatments. Tensile test. In order to obtain the nine independent constant values of the stiffness matrix, have five samples built with the different orientations have to be tested. As no special standard exists for RP parts, the samples have been prepared according to the geometry and dimensions specified in the ISO standards. So, tensile properties of isotropic and orthotropic fiber reinforced plastic composites. In this diagram, we can see the picture about the sample manufacturing position in strategy. It's the material employed was the P4OO ABS, which contains 90 plus or minus 99% acrylonitrile butane styrene resin, 0 plus or 2% mineral oil, and 0 plus or minus 2% wax. And the physical properties are tensile strength and 0.034 megapascals, flexural strength and 0.066 megapascal, tensile modulus 2.48 megapascal, and flexural modulus 2.62 megapascal, and 50% of elongation among others. The material filament is drawn into the FDM head from the spools by drive wheels where it is melted by the liquefier. The temperature of the liquefier is around 270 degrees centigrade from the ABS plastic, and this material is extruded out of the FDM tips where it is solidifies, strings and fuses to previously deposited materials. As FDM head is moved in the horizontal plane, means XY plane. A road width of the 0.60 mm was used and a layer height of 0.25 mm was selected. Stiffness matrix. Mm, Once tests have been performed graphs and valued obtains in them allow us to get engineering constant in the three directions, and equations of Hooke's laws can be written as the equations, and the formula should be typed in the math type and numbered conse- consequently with the Arabic numerical in parentheses on the right hand side of the P. Uh, they should also be separated from the surrounding text of this one of the space. Result. To modeling the geometry of a dog bone sample used in the experimental test, a model was designed in the design after geometry definition, mesh and boundary condition, layer orientation known, and element sets were created, and then joins them together in ABAQS input file. For two compared models, geometry and material orientations were the same. Boundary conditions have been adapted to simulate the same test in the both cases. Originally, this model was developed to accept 0% and 90% layer orientation. However, the model is easy to expand to work with another layer orientation by changing some inputs. Result is obtained shown that the failure can be underestimated when the part is designed, considering as a rigid orthotropic material. However, when model is designed as a layered part, taking into account the effect of delamination due to stresses and failure transmission between the layer interfaces. It can be seen that a part reach highly one is stress value conclusion. When a composite laminate is made from layers, its properties are controlled by the number and the different orientations of the plies depending on the fly's final surface of the laminate. uh, its strength and stiffness value can be configured and tailored selecting the orientations of the each lamina. However, the laminates are usually bonded together with a minimum reinforcement between them in thickness direction. So not only the failure in single ply can be considered, but also the failure of the interface between them. In the present study, some different orientation configurations will be seen and analyzed, and both of the failure modes will be considered. Parts manufacturing using this technology can be considered as an orthotropic for FEM model or finite element models. Some deformations and stresses failures difference have been found between a model made as a solid part and another model made taking account each layer as solid and union forces between layers to analyze the mechanical characterization. Thank you.